Lesson 6, Optimization Problems. Our goal for this lesson will be to use a variety of strategies for determining the maximum or the minimum value of a quadratic function. In mathematics, optimization problems are those where you're asked to find the maximum or the minimum value of a function. For quadratic functions, the maximum or the minimum value is the y-coordinate of the vertex. This point is very important to helping you solve word problems related to this unit. Essentially, in this lesson, we're going to be finding the vertex, and then the y-coordinate of that point will be our maximum or our minimum value. There are 3 ways to find the vertex, and we're going to look at all of them in this lesson. The first one is completing the square. That should be a review of grade 10. The second one is using the zeros or the x-intercepts. We looked over this in lesson 2. And finally, the technique of partial factoring, which is brand new and we'll learn it for the first time here. Let's go through each of the methods next. First up, we have completing the square. We're going to begin with a quadratic function in standard form. F of x equals ax squared plus bx plus c. Here is the recipe for completing the square. The first step to completing the square is to factor out the a value, but only from the first 2 terms, and this is shown below. If you factor out a from the first 2 terms, then you're left with a multiplied by x squared, because we factored out the a, plus b divided by a multiplied by x. We're dividing b by a because when you factor, you divide each term by the value that you're factoring out. Put brackets around those first 2 terms and then just leave your c value. We don't factor out a from the c value. In our second step, we add and subtract the term b over 2a all squared. By adding and subtracting the same thing, you're effectively adding 0, which doesn't change your expression, but doing this ensures that you have a perfect square trinomial, which you'll be able to factor later. This is algebraically what it looks like to add and subtract b divided by 2a all squared. So look at the line below here. I'm going to highlight what we did. We added the term b over 2a squared, and we also subtracted the term b over 2a squared. That's what's different from the first line to the second, but once again notice, because we're adding and subtracting the same thing, we're effectively adding 0. And that's allowed in mathematics because it doesn't change your overall expression. After doing that, you've set up the conditions for a perfect square trinomial. The first 3 terms in the brackets of the second step will always be able to factor as a perfect square. I'm just going to circle here what the perfect square is. And those 3 terms are the conditions of a perfect square. So we factor it in the next line, which I'll highlight below. Okay, notice that expression results after factoring a perfect square. And we're left with that negative b over 2a all squared term. What we finally do is distribute the a value to both terms inside of the bracket, and that's going to leave you to this expression shown below. Just as a disclaimer, when you're looking at it in terms of a, b, and c, it can be hard to follow. That is the general recipe though. We're going to do an example next, which will make much more sense of this procedure. It may not be immediately apparent, but h, which is the x-coordinate of the vertex, is equivalent to negative b divided by 2a. And similarly, k, which is the y-coordinate of the vertex, is equivalent to this expression over here. This isn't something to memorize, but it results from completing the square of the general quadratic function f of x equals ax squared plus bx plus c. Let's show you how to complete the square in a tangible example. In example 1, we're asked to determine the maximum or the minimum value of each quadratic function by completing the square. I'll demonstrate by following our recipe. So to begin, the first step requires us to factor out the a value from the first two terms only. This is shown here. Don't factor it out from the c value, we'll just write that down. The second step of our recipe requires us to add and subtract the term b over 2a squared. In our case, b divided by 2a is equivalent to negative 3. So we're going to add negative 3 squared and similarly subtract negative 3 squared. Close your bracket and you're still adding the 31. If you're not sure where the negative 3 came from, go to the original quadratic function. Our b value is negative 24. We have to take that and divide by 2 times a, or 2 times 4, which is 8. So negative 24 divided by 8 gives us negative 3. That's the value that we have to square and then add and subtract. Continuing on, we can begin simplifying now. So inside of the brackets, we have x squared, take away 6x, plus 9, take away 9, close your bracket, and then we add 31. Now here's a very common mistake. Inside of the brackets, you'll see that we have a plus 9 and a minus 9, and at this point, students are very tempted to cancel them out. Don't do that. If you do, you'll just get back to the first line that you started with. So here's where we're going to use completing the square to our benefit. Notice that the first 3 terms inside of the brackets, which I'm highlighting here, these 3 terms form a perfect square trinomial. In other words, what 2 numbers multiply to 9 and add up to negative 6? So we're going to go ahead and factor that as a perfect square. This will be shown next. The 2 numbers that multiply to 9 and add up to negative 6 are negative 3 and negative 3. So those first 3 terms factors as x minus 3 all squared. Then inside of the brackets, we're left over with the negative 9, and then we have the plus 31 outside. After doing that, we distribute the a value back into the square brackets. So doing that, we have 4 times x minus 3 all squared, and then 4 times negative 9 gives us negative 36, and we still have that plus 31 left over. Now collect your like terms, so we have 4 times x minus 3 all squared, and finally negative 36 plus 31 reduces to negative 5. And we'll take a moment to stop here. So let's just note what we did. We took a quadratic function that was originally in standard form, and through the method of completing the square, we converted it into vertex form. And that's essentially what the goal of this lesson is. Because just to remind you, we want to determine the maximum or the minimum value of each of the following quadratic functions. Vertex form is the best form to tell you the max or the min. Note that our a value is positive, that's the 4 in front of the brackets. Because the a value is positive, that tells you that your parabola opens upwards. I'll just make a sketch over here. And therefore, the minimum value is going to be the y value of the vertex. Make sure you understand from a graphical perspective that the minimum or the maximum is just equivalent to the y coordinate of the vertex. And that's our k value. So therefore, the minimum value of this function is negative 5. And note that negative 5 is just simply the k value, which I'll highlight over here. All right, moving on to example B. Give me a moment here. I need to give myself a little more room for this next example. Let's begin by following our recipe. We factor out the a value from the first 2 terms of the expression. So we're going to factor out a negative 3, which is going to leave us to x squared take away 5 over 3 times x. Now notice that 3 doesn't go into 5 evenly. That's fine. Just leave it as a fraction. The next step of our recipe requires us to add and subtract b over 2a squared. So our original b value is 5. 2 times a will give you negative 3 times 2, which is negative 6. So we're going to add and subtract 5 over negative 6 squared. This will be shown next. So inside of the brackets, we're going to add and subtract. Five over negative 6 squared. Let's simplify that. So we've got negative 3 multiplied by x squared. Take away 5 over 3x. And now we're going to square 5 over negative 6. So when you square a fraction, don't forget to square both the numerator and the denominator. That's going to give you plus 25 over 36. And similarly, we're subtracting 25 over 36. As before, the first 3 terms inside of the brackets will always factor as a perfect square. So I'll do that in the next line. That's going to factor as x take away 5 over 6 all squared. And we're left with the negative 25 over 36. In our next step, we distribute the a value of negative 3 to give us negative 3 times x minus 5 over 6 all squared. And then negative 3 multiplied by negative 25 over 36 gives you positive 75 over 36. And finally, we can reduce the positive 75 over 36 as follows. In lowest terms, that fraction reduces to positive 25 over 12. In summary, notice that now our a value is negative. That tells you that the parabola is going to open downwards like this. So now we're going to have a maximum value, and that maximum value is just the y-coordinate of the vertex. So therefore, the maximum value is positive 25 over 12. And that's our first method of finding the maximum or the minimum value of a quadratic function. Our second method involves using the zeros. Now, we actually reviewed this in lesson 2 of this unit, but we'll do it again here just for completeness. So given a quadratic function in standard form, we use the zeros to find the vertex. Begin by setting your quadratic function equal to 0, and then factor it and solve by factoring. Once you solve by factoring, that'll allow you to find the roots. If you can't factor, use the quadratic formula to find the roots. The x-coordinate of your vertex then is just simply the midpoint of the two x-intercepts. Here's this formula we've seen before. H, the x-coordinate of the vertex, is equal to r plus s, which are the two x-intercepts divided by 2. If you then simply substitute that h value into the function, the output will give you the y-coordinate of the vertex or the k value. Let's practice with an example. We're asked to find the maximum or minimum value of the following quadratic functions by using the zeros. I'll demonstrate with example 2a. If possible, we should always factor because it's definitely easier. So here's a simple trinomial. We want two numbers that multiply to negative 2 and add up to negative 1. Those two numbers are negative 2 and positive 1. Now that we factored it, we set our quadratic function equal to 0. and solve by factoring. So it's already factored. This is going to lead to two solutions. One value of x is positive 2, and the other value of x is negative 1. Those are your x-intercepts. So the x-coordinate of the vertex, or the h value, is just simply an average of the two. So 2 plus negative 1 all over 2. That's going to give you 2 take away 1, or positive 1 all over 2. So we get an h value of 1/2. Finally, to find the y-coordinate of the vertex, which will be the maximum or the minimum value, we input the h value into the function. Please plug it into the original function. So we have an input value of 1/2. And simplify. So 1/2 squared is 1 over 4. Take away 1/2, take away 2. Okay, we've got some fraction math now. So I'm going to make the 2 over 1 so that I can add and subtract my fractions. So this is 1 over 4, take away 2 over 4, take away 8 over 4. And all of that simplifies to negative 9 over 4. Now we have to conclude. So notice that we have an a value of positive 1. That's the coefficient of the x squared term. Since it's positive, that means our parabola opens upwards. And therefore we have a minimum value of negative 9 over 4. All right, let's try another one. In example 2b, you're going to recognize that this quadratic function can't be factored. Because it can't be factored, I'm going to go ahead and use the quadratic formula to find the two roots. Here we go. So using the quadratic formula, we have x equals negative b plus or minus the square root of b squared minus 4ac, and that's all divided by 2 times a. Plug in your a, b, and c. And we'll start simplifying. So this is negative 6 plus or minus. Now under the square root, you're going to have 36 take away 4 times 2 times 2. That's essentially 36 take away 16, which will give you 20. We have a radical, root 20. Going back to what we learned in lesson 1 of this unit, you can simplify that as 2 root 5. And that's all over 4. Okay, and there you go. We have our two x-intercepts, so I'll just write them out explicitly here. One of them is going to be negative 6 plus 2 root 5, and that whole expression is over 4. And the other one is going to be negative 6 take away 2 root 5, once again all over 4. So let's find the h value, which is the x-coordinate of the vertex. This is equivalent to r plus s all over 2. I'll write that out over here. So here's our r value, negative 6 plus 2 root 5 all over 4, plus s, which is negative 6 take away 2 root 5 all over 4. And in brackets, that's just r plus s. And I'm going to divide it by 2, and I'll write it like this just to save a little bit of space. Now notice very conveniently inside of the brackets, everything is over 4. So we can just go ahead and add the numerators. And you'll see something very convenient happens. Notice that the positive 2 root 5 cancels out the negative 2 root 5, leaving us with just negative 6 plus negative 6, which is negative 12 over 4. And now we have to do negative 12 over 4 divided by 2. And negative 12 over 4 is just negative 3, So this whole thing simplifies to negative 3 over 2. Finally, to find the y-coordinate of the vertex, we just substitute negative 3 over 2 into the original function. So here, f of negative 3 over 2 is, let's go back up and look at our function. So 2x squared plus 6x plus 2. I'll try to remember that. So 2 times the x value squared plus 6 times x plus 2. Just to make sure. Yeah. All right, let's simplify that. Some more fraction math. So 2 times negative 3 over 2 squared, that's going to give you 9 over 4. 6 times negative 3 over 2, that's negative 18 over 2, which is just negative 9. And then plus 2. Continuing to simplify, 2 times 9 over 4, that's 18 over 4, which reduces to 9 over 2. We've got 9 over 2, take away 7. That 7 is over 1. So as a final simplified answer, 9 over 2, take away 7 over 1. That's going to give you 9, take away 14, all over 2, which is equivalent to negative 5 over 2. And there you go, everyone. That's the k value, or the y-coordinate of the vertex. Please recognize that you have an a value of 2. That's positive, so the parabola opens upwards. That suggests we have a minimum value. So therefore, the minimum value is negative 5 over 2. Moving on to our last method called partial factoring. Now this method is brand new. You likely haven't seen it before. Here's how we use partial factoring to find the vertex, which, remember, tells you the maximum or the minimum value. Once again, we're given a quadratic function in standard form. The method of partial factoring involves the following. The very first step is to let f of x equal the y-intercept, which is basically the c value. So you substitute f of x equals c, and because you have the same value on both sides of the equation, they cancel out, giving you ax squared plus bx equals 0, a much simpler looking quadratic equation. What you then do is factor out the greatest common factor of the two remaining terms. And then you just repeat step 2, which is finding the zeros and using that to determine h and then k. This will be demonstrated in example 3. So example 3, once again, is very similar. Find the maximum or the minimum value, but this time using partial factoring. So notice we have a c value of positive 14. The first step involving partial factoring requires you to substitute 14 for f of x. Doing that gives us the following. And because you have 14 on both sides of the equation, they cancel out, leaving you with 0 equals negative 2x squared plus 6x. Now we factored the expression on the right-hand side, so we're going to factor out a negative 2x, that's our greatest common factor, and that leaves us with x, take away 3 in brackets. This gives you two solutions. The first one is that x equals 0, and the second one is that x equals 3. And we repeat what we did in step 2. So the h value is just an average of the two x-intercepts, so that's 0 plus 3 all over 2, which gives you 3 over 2. And then we substitute that into the original function, and that'll give us the k value. So next we evaluate f at 3 over 2. Okay, and to save a little bit of space, we'll just do this in one shot. As a simplified fraction, this will work out to be 37 over 2. Because our a value is negative, that means the parabola opens downward, suggesting that this is a maximum. So therefore, the maximum value is 37/2. Let's do one more in part B. So we repeat the same steps as before. We let f of x equal 35. The 35 on both sides of the equation cancel out, leaving us with the following simplified quadratic equation. Next, we factor out the greatest common factor. In this case, it's negative 5x. And that gives you x take away 6. And as before, we have two zeros. The first one is x equals 0. The second one is x equals 6. Our h value is just the midpoint of the two. This one will work out to 3. And finally, to get the k value, substitute 3 into the original equation. This simplifies to negative 45 plus 90 plus 35. After adding up all of your like terms, you're going to get a final simplified answer of positive 80. Once again, we have an a value that's negative. That tells us the parabola opens downward, so we'll write a therefore statement. The maximum value is positive 80. And now you've seen three ways of finding the vertex of a quadratic function, which allows you to determine if there's a maximum or a minimum value. This lesson focuses on word problems for the most part. You're welcome to use any of the three methods that you'd like. It's good to be familiar with all three, but practice on the one that you're most comfortable with. We'll see how to do this in example 4. So this is a standard word problem when it comes to quadratics. We're modeling the height of a football by the following quadratic function. And we want to determine what the maximum height is. So because we're asked to determine the maximum height, we need to find the y-coordinate of the vertex. To do this, we can use any of the three strategies learned in this lesson. In this example, I'm going to use partial factoring. So I'm going to substitute 1 for h of t, as shown here. The 1 on both sides of the equation cancel out, leaving us with a much simpler quadratic equation. On the right side of the equation, I'll factor out a greatest common factor of negative t. That leaves us with t minus 3 in brackets. And now we solve this by factoring just like we've done before. So we get two solutions. The first one is t equals 0. The second one is t equals 3. The vertex will be at the midpoint of these two values. So h equals 0 plus 3 all over 2. That simplifies to 3/2. And finally, to get the maximum height, we just plug this into the equation. So h of 3/2 equals negative 3/2 all squared plus 3 multiplied by 3/2 plus 1. All right, I'll let you work this out. You can do this by hand or punch it in on your calculator, but you should get positive 13/4 as your final answer. Because our a value is negative, the football will reach a maximum height, so therefore The maximum height of the football is 13/4 meters. Here's your recommended homework for this lesson. Try as much of it as you can. Thanks everyone. Take care.